share this fully. Let's
Started.
Okay. It's starting. Cool. Let me present. Okay. Well, hello everyone that's out there. This is going to be a quick little tutorial about using Arduino, and obviously because we're all virtual, we're not going to be doing it with hardware, but we're going to be doing it through this online software called Tinkercad. So if you don't have an account already, go ahead, go to tinkercad.com, create one, sign in. I'll show you how to navigate it, but get that going just so we can get started all together. Let's take a look. So, of course, this is going to be more of a basic tutorial, like an introduction to Arduino. I'm no expert. I'm definitely just, I just started learning this stuff myself this year, and I was looking to share some stuff I've learned with you. There is, what's it called? I did not come up with this lesson, by the way. I based it off of, let me move this guy, the Electronics Guy YouTube channel. If you're interested in learning more, he has lots of great videos. I'll definitely recommend checking him out for more advanced stuff beyond this. But regardless, today we'll be looking at measuring temperature. And so we'll cover an overall overview of what Arduino is, what you can use it for, its pros and cons, the component and code description, talking about the hardware and the software we'll be using, and also walk you through it live, going through the steps, how to connect the circuits, things like that. So what is Arduino overall? It's one of the most famous, probably the most famous open source electronics platform at this point. It has a low cost of entry, so it's used anywhere, from graduate school projects to elementary school, first coding classes and things like that. The reason it's so useful for prototyping is it's very compatible with different kinds of operating systems, whether it's Linux, Macs, or Windows. And as I just said, the low cost of entry makes it very accessible to different kinds of people. And also it has a lot of different instruments that you can use with it. So today we'll be using a temperature sensor. Tinkercad, on the other hand, is directly associated with Autodesk, the producer of AutoCAD. It's a free online software tool. It's completely open to everyone. And a lot of people kind of give it a bad name because they see it as pretty simple. But I really enjoy using Tinkercad just because it is such a great learning tool. You can make very clear circuit diagrams with it. And it's a great way to get started with something more versatile and honestly confusing like AutoCAD in a more friendly setting. So Tinkercad is also another thing that is used oftentimes as an educational thing, but you can use it to create 3D models. You can use it for 3D printers. And so it's still a very versatile instrument, even though it's more pared down than AutoCAD might be. So the physical components we're working with here, the main most important thing is the Arduino Uno board. So what the Arduino basically does is it can send and receive inputs from computers, sensors, other Arduinos. And it does this through use of a microcontroller, which you can see labeled right on the slide. What the microcontroller basically is, I'm gonna botch this, but it's basically a mini computer. And so it doesn't have all the functionality, but it can send data, manipulate it, receive data, and also store the code you send to it. Now, the way it interprets this data is through what's known as analog to digital converter, or ADC. These are called the digital pins, or rather, sorry, these are called the analog pins, and they're able to receive analog signals, whether real world signals that a thermistor or an oscilloscope might send, and it digitizes it into something the computer can read. And of course, as you can see, there's a component to plug it into your computer, place to power it, and also there's a digital pins which send and receive digital signals. As for the breadboard, breadboards are very useful for fast and easy prototyping. It basically allows you to create circuits without any soldering, which means you can reuse, change it around, mess with it all really fast. The main thing about it is that these connections on the outside run lengthwise, so anything wired there will be connected. And these connections run, I guess you could say, widthwise, they run up and down. And so anything connected in one of these columns is going to be connected all together. That'll come into play when we're making the circuit. Oh, and of course, Ananya Mahika, let me know if there's anything you want me to clarify or restate or anything like that. As for the hardware, let's take a look at this stuff. So what we'll be using to measure temperature is what's known as a TMP36. It's not a thermistor or a, what's the other one that people often use? A thermocouple. Those are both instruments often used to measure temperature, but it is another kind of solid state temperature sensor. Solid state meaning nothing's moving around. It's all just packaged in nicely, which means it's very durable, consistent, and inexpensive. Less moving parts means less expensive. It's quite accurate. As you can see, it has, or not accurate, but quite precise with a 0.1 degrees Celsius precision and an average range of about -40 degrees Celsius to 150 degrees Celsius. So very cold to very hot. The way it works is that the diode within it, basically the potential difference varies linearly with temperature. And so if you can measure that potential difference that changes with temperature, you can convert that voltage signal to a temperature reading. Very useful. As for the LCD we're using a liquid crystal display, tiny little sensor. The great thing about this is if you have one of those Arduino kits, then you most likely have the one with this exact same sensor. So anything we do here today, you can transfer over and use it with your own equipment. I think most of the Arduino kits that we send out might have it, but double check. If not, they're again super cheap, easy to grab, and they can be pretty fun for printing stuff out besides just temperature. Oh, and it also contains a microcontroller to interpret the text-based signal that the Arduino is sending. Okay, moving forward. We're going to talk about the code a little bit and kind of dissecting its different anatomy parts. The first part of any Arduino code, and let me actually say here, Arduino code is based for the most part on C or C+. And so, one of them, C+. And so C++, I have a friend helping me out here. All right. And so it's going to be very similar if you have some experience with it. I did not. And so it's a little different from things like MATLAB or Python that you may have encountered before, but it's still very accessible and easy to get into. First thing you usually do is you initialize your variables and you include any libraries you'll be using today. Then you set up the code, which is run once in this section. You have a loop section, which runs indefinitely. And that's usually where you put your the main part of your code that you want to repeat. And finally, you have any functions you define at the very end. So for this part, we're looking at sections 1 and 2 here. As you can see in the top, this hashtag include, or whatever you call it, $include, this tells you to include a particular library, in this case, the liquid crystal. One thing that's really useful about Arduino is people and Arduino company itself have created thousands of libraries for different uses. This one is specifically for using the liquid crystal display. And as you can see, the first variable we define is a liquid crystal variable. Those numbers that you see in the parentheses represent different digital pins that the LCD will be receiving information from. And this is how it knows which particular pins to look at. Or rather, this is how the Arduino knows which particular pins to send information to the LCD. Then we define an integer variable for the sensor input, and then a float variable for temperature. Integer and float, they're both kinds of variables for numbers. Integer just means it has to be a number. Float has a very large range, and it can be a decimal number, a fraction, irrational, whatever. And then over here, you see the second section, we have our void setup. This serial.begin, this sets the baud rate, which is how fast the Arduino can send and receive information. Here we've set it to 9,600 bits per second. And then here we initialize, or we begin, as you can see in the function, our LCD, and that tells you how many rows 16 rows, and how many columns of text you will have. Moving forward, we're looking at the other sections. This loop section, as you can see, we have two functions which we define in our code. One measuring temperature, the other measuring the other sending the display temperature. And when you define a function, you always want to make sure it comes at the end of the code. That's just kind of how Arduino and most other workspaces read it. And so you have to make sure that you're defining it at the end. As you can see here, we have our first one, which measures the temperature from the TMP36. This analog read tells you to read that certain pin that we wired the sensor to. Over here, we have the sensor input, which is getting divided by 1024, which is the bits of information that we have available. And then here is where we perform the calculation to turn the temperature into, we'll return the received signal in voltages, or actually in an arbitrary bit number into a temperature. Over here, we have our display temperature function, which essentially just says, okay, print it in the Arduino and then also send it to the LCD screen. The delay is just to give you some time in between readings. How's my internet connection? It just came up that I went unstable for a second.
Yeah, I think we lost you for a second, but I don't think we missed anything. I think we still caught it all.
Cool. Okay. I'll keep moving forward then. Okay. And then here's the overall design of the circuit. I'll walk you guys through it, but I just wanted to give everyone a quick overview first. As you can see, we make use a lot of the fact that these columns are wired together and these rows are wired together. And I'll go into a little bit more depth explaining everything. But this is without the LCD. This is with it. With that, unless you guys have any questions, I can start going through it, showing everyone how to put it together. I think I'll go ahead and get started then. Okay. So when you sign into Tinkercad, you'll be directed to this area. You're going to want to go down to circuits, which is the one we're currently on. And you're going to go ahead and create a new circuit. I'm going to go into the one I have prepared for this workshop. Tinker this. Again, Electronics Guy, the Electronics Guy, great resource on YouTube. This is where I got the code and the design for the circuit. So that being said, let me see if I can zoom out a little bit. And I'm going to delete this so we can together. Okay. Okay. Okay, now we got all that out of the way. Let's go ahead and get our first two components, the breadboard. And all you gotta do is just click and drag. It's really easy like that. And we're also gonna grab our Arduino Uno. It's the only one they have on option, but it also has everything that we'll need. Okay, let's zoom out a little bit. Now, the first thing you wanna do, or the first thing I usually like to do, is let me zoom in a little bit more. Ooh, too much. My mouse died on me, so I'm using my trackpad. But can you guys, is this big enough? Can you guys see this all right? Cool. First thing you'll want to do, connect the 5-volt, which is a 5-volt power supply directly from the Arduino, to our board, and also the ground. Ground is basically, you can think of it as like a safety. It makes sure that no drastic surges go through any sensitive electronics by receiving any extra electricity or current in the circuit, so it doesn't damage the Arduino or your sensors. Convention goes that you make ground black and power red. So let's go ahead and do that. Okay. Moving forward, you're going to want to connect this to your column. Connect another ground to your column. And also add in what's known as a potentiometer. What the potentiometer basically does is allows you, well, the LCD, I'll start with this. The LCD can vary in its brightness, and the potentiometer allows you to essentially turn on the LCD with enough power for it. 10, let's send this to 10. This wire is going to be sending that to the LCD. Oh, let me check my messages. So Mahika had a great question, but when you're wiring in parallel versus series, most of the time you're going to want to wire in parallel, at least for these projects. The main reason is that you don't want your instruments, which are all most of the time voltage based, to be affected by any previous or following instruments and their differences in voltage. So in order to avoid that, you wire things in parallel, which allows each instrument to have the same supplied voltage from the Arduino itself, and it prevents any interference from other instruments. Everything we'll be wiring here today will be in parallel. There's really only two instruments, so even though it may not look like it, the TMP and the LCD both are wired in parallel. Let's go ahead and make these guys white. I do apologize. This is going to be one of the slower parts of the workshop, but I promise you it should work by the end of this. Let's go ahead and add in our TMP. TMP. V out. There's 3 pins. There's a power pin, which comes straight from the Arduino, a voltage out, which of course comes, is the information that the voltage signal that's being read, and then a ground, which most instruments will have, again, to prevent that additional current from damaging any instruments. And I don't know why, but myself included, everyone always seems to make their information wires blue. We're going to be connecting to analog pin A0. And so I'm not one to go against the grain on stuff like that. Information is blue for me. Okay. Let's keep moving forward. Let's connect our ground and power to the opposite rail. Just like that. We're going to need one resistor, which you'll see coming in handy. Resistors are another thing that limit current through a circuit. Again, most of the time, almost as a safety kind of precaution, and it'll be the same thing for this case. 220, let's make this guy 220, not the name, 220 ohms. Okay, let's see. Next things next is going to be adding in, I think we can go ahead. Oh, and don't forget, we're also going to need another connection to ground here. Okay, now let's go ahead, add in our LCD. Again, you should have this, if you have an Arduino kit, you'll most likely have something that resembles this. So you'll be able to use the library that we use today, as well as some of the commands here to, to display your own text with an Arduino. Let us go ahead and I'm gonna move this a little bit closer so I can see what I'm doing. Perfect. You want the last black wire or the last ground to be lined up with that last LED, and the resistor to be lined up with the second to last LED anode. One's the anode, one's the cathode, positive and negative. Then first things first, connect ground to ground. It's kind of just like connecting the dots at a certain point. Connect VCC, which usually means supplied power, to our power rail. And as you can see, we have two instruments, one and both connected in parallel. The TMP has its own independent connection to the power system, and the LED screen, or the LCD screen, has its own independent connection to the power rail as well. If we did them in series, the whole thing would be messed up. There wouldn't be enough power for everyone. And so you really want to make sure when you're doing these, you're wiring things in parallel. Okay, now we have a whole mess of wires to connect. VO, that varies the contrast, and that's why we want to connect that to the potentiometer. Varies the contrast of the screen. Let's go ahead. And then I honestly do not know what a lot of these different pins do, but they all have to be connected to those original digital pins that we set originally in our code. So VO R5 is going to be connected to D13. Let's go ahead and do that. And when you're making these wires, if you tap once, you'll be able to round a corner. I'm sorry, I didn't mention that earlier. Yeah, if you tap once, you'll be able to round a corner, tap again to round another one, and then tap on a pin to connect it. You have to connect it somewhere. And so that usually can be a little frustrating to get used to at first, but eventually you get the hang of it. D12 is going to be connected to, I believe, RW. Or rather, excuse me, D12 is going to be connected to E. Let's go ahead and do that. RW is going to be connected to ground. Moving forward, let me zoom in on the one I have over here, but it seems as if DB0 through DB3 is not connected to anything. So the main connections we've made so far are the ground, the VCC, VO, R5, RW, and E. DB0 through DB3 don't got to connect to anything just yet. We'll connect DB4 to pin 12, or not pin 12, pin 11. Go ahead and do that. There you go. DB5 is going to be to pin 10. And I promise you, we're almost done here. With the circuit, that is. DB6 is going to be, let me get rid of that pop-up. DB6 will be connected to 9, as could be expected. And then finally, DB7 is going to be connected to D8. Okay, that should be all of our connections. Again, as you can see, I got a little lazy with where I'm connecting things. Sometimes I do it to the board, sometimes I do it to the adjacent column. It doesn't matter because they're all connected. But if you're worried about that, you can go ahead and connect things just like that as well. Okay, if I'm not mistaken, that should be our correctly connected wiring. I can change some of these colors just so it's a little varied over here. But the next thing we're going to focus on is not the physical hardware, but instead our code for this. And that's going to be reflective of what we talked about earlier. Let me add in the rest of these guys. There we go. Okay, so the way you manipulate the code is quite simple. You go to code, this tab over here, click on it, and you have actually a couple different options. So you can do what they call block notation, which is, again, what a lot of people use in schools, I believe, to teach, middle schoolers, high schoolers, honestly, anyone that's new to coding. But for now, we'll be using the text because that's what the more conventional method. So go ahead, click on text, click continue. We don't need any of that stuff. And I like to write my code rather than copy paste it, even though if I am, getting it essentially just copy pasting it, because I think it gives you a better chance to analyze the code as you write it. And, I think it's just good practice. The goal is to be able to do it by hand, right? So let's check this out. First thing we have here, I'm going to credit the creator of all of this. Credit to the electronic guy. And first thing we're going to do, include that library. All libraries have that .h extension. And next, at least for Arduino, I believe, maybe. And let's create that liquid crystal variable with the appropriate pins that we just assigned, or that we just physically or virtually connected it in Tinkercad. 10, 9, and 8. Then let's initialize our other variables, the sensor input, the float for the temperature, and let's go ahead and create our void setup. Again, I am no master at coding. I'm very much a beginner, but usually the void setup, the lack of anything in between the two parentheses, represents the fact that you're not inputting anything and you're not receiving anything out of it. Again, with much more knowledge, we'll probably have a better explanation. But in layman's terms, it's not that important right now. Yeah, definitely if I say anything wrong, please correct me. That's also the void. Perfect. Okay, let's set our baud rate. 9600. Let's begin our LCD variable with 16 columns and 2 rows. And do you guys know if you absolutely need the semicolon, or is it optional like in MATLAB? Yeah, I'm pretty sure in one of these languages the semicolon is imperative, so always good to have. I think it has a more important functionality than in MATLAB. Here we're going into our loop section, where we call our 2 variables that we're going to write in just a minute. Not even variables, our 2 functions. And that's it for our loop. Let's go ahead and create our 2 functions. The first one is measuring temperature. Let me check this guy real quick. Oh, then thank you very much. That is the danger of coding live. One of my greatest fears. How do you spell measure? There you go. Open up those brackets. Anything within the scope of the brackets will be included in the code. And so you want to make sure that you only have things for that particular section within those brackets. That's another thing that's kind of imperative. So we're going to define our sensor input variable as the analog reading of our A0 pin. And this basically tells Arduino, see what voltage is being read at this particular pin, which we've connected our TMP sensor to, and turn it into a, what's it called? Or turn it into a digital signal. That's the analog to digital converter aspect of all that. Let's initialize our temperature. perform, this is a simple voltage divider equation. And also, I think is what you want, a temperature signal in degrees Celsius. Okay. Yeah, I'm getting that same internet connection. Am I okay so far?
Yeah, I think we again lost you for a second, but you said something about degrees Celsius. Could you just clear that up like once more? Sorry.
Yeah. So all I was saying is basically think of all this junk, these different calculations, as what you're doing in order to convert the raw voltage signal into a usable temperature reading in degrees Celsius. Part of it is just the voltage divider equation, and another part of it is unique to the TMP sensor itself. Okay, let's go ahead and create our last variable, or not variable, I keep saying that, our last function. Using a lot of those library functions that we had earlier. LCD set sensors from the LCD library, as LCD print, LCD set cursor, things like that. Serial print, though, is what allows us to print into the Arduino workspace. And anything that you want to print, you have to make, if it's text, you have to make sure it is in quotations. If it's a variable, you can go ahead, as you see in this next line, and just stick in the variable. No quotations needed. In fact, you don't want to use quotations so that the software knows that this is a variable and not text to be displayed. Finally, serial.print ln. ln stands for line, tells you to skip a line. Next, we are sending information to our LCD screen in Celsius. Similar rules to the serial.print. You want to make sure everything is in quotations. Set cursor to a value farther along, 5, 1, so that basically the 5 and 1, as I referenced earlier, that refers to what row and what column to start that next line of text. So 0, 0 tells you to start at the very top row, top column. 5, 1 tells you to go to the 5th row in the first one. Or rather, I think I had that backwards. It's the 5th column in the first row. First column, second row, something like that. It works out in the end. And finally, LCD print again, that temperature we calculated from before. Delay 500 milliseconds. Okay, so I'm going to do a quick overview, make sure that I wrote everything correctly. We have included our LCD library. We have our digital pins that we are sending our data to in our Arduino. 2 variables, baud rate of 1600, 16 rows, 2 columns, a looped section, which is measuring temperature and displaying temperature, and then our 2 functions. I think we can go ahead and close this, and fingers crossed, we're going to run it. You guys can run along with me and see if this works out. Start simulation. That tells you to start running the code. And obviously, I do have some errors going on. Let's double check what we got here. Now, some of these errors can be a little intimidating at first, but I try copy paste into Google. They usually give you a good shot at it. And also reading through it, if you just take the time to kind of look through it, you're usually able to decode what they're trying to tell you. So the first one it's telling me is expected a comma or a, what's it called, before integer. Let me see. I believe I forgot to put a semicolon after my library, right there. Anything else? Sensor input was not declared in this scope. Again, the dangers of coding live. Let me double check. Forgot to capitalize. As you can see, I am definitely not a perfect coder, and but it's good to know common mistakes. Forgetting a semicolon, miscapitalizing something. Let's see what else they got me on. Since input was not declared in the scope, and function has no member named temp. Let's go around and check this out. Probably gonna get some help right now. All right. Yes, this was planned. This is part of the lesson. I'm trying to make sure I can grab it. See if it likes that a little bit better. Okay, in function, void display temp, no hardware. Let's see, what is different about what I have over here? Let me go ahead, copy paste what I have over here. In the last 10 minutes, let's see if I can fix this. All right, I know I went on that high horse of not copy pasting, but sometimes you gotta copy paste. And I'll send this to you, Mahika, so that you can include it with the lesson as well. Let's try that out. There you go. Miraculously, it happens. So some things we got to change. As you can see, the sensor or the LCD only works with that potentiometer turned all the way up. So first thing to change, and as we can see, according to our TMP model, it should be reading about 25 degrees. That's what we're getting over here. If we move it up, you can go up to 98 degrees around boiling, move it all the way down. You can get close to -40, which is terrifying. And basically at this point, you have a very simple, yet very hard-fought thermometer. Congratulations, you can now measure temperature. But let's see, did you guys have any other things you think I can clarify a little bit more? That's kind of the end of the workshop.
I think this was great.
Okay.
Like, at least, well, I mean, I'm just interested to see what else you can do on Tinkercad for, like, I didn't know that it was also a simulation kind of software. I honestly thought it was just like you could plan out the circuit diagrams and things like that. But that's really cool that you can simulate things here.
Yeah, we used it for MA 170, which is how I found about it. And it didn't work as so well in 170 because I think the stuff they were trying to do was just too complicated. And I also didn't know what was going on. But for, I have an easier time understanding simpler stuff like this.
Is it generally used, like, at least with Tinkercad, do we generally use it to like test out a certain circuit to see if it would work, and then we can like build it out and try it that way?
That's definitely something. Depends. The limitations in Tinkercad come when you don't have the instrument you need. Like for example, the only temperature sensor they have on Tinkercad is a TMP, not a thermocouple or a thermistor, which are honestly much more common.
Right.
But it's good for, I think it's good for drawing out circuits. So you can be, it's, you know, rather than making something, sending a picture to someone, it's much more clear with these diagrams, I think.
Okay.
And there's a lot of stuff you can do with Tinkercad, even with its limitations. There's an oscilloscope, you know, if we want to look at some of the other components you can have, you know, there's a whole lot. Buttons, switches, photodiodes, force sensors, microphones, LEDs, more than you could probably really need, but also not a ton. But I used it in my other independent research project just to like communicate our circuit diagrams.
That's great. It definitely seems super useful for that. And like, it is pretty organized and kind of nice to see.
Yeah. Mhm. Let's see. Anything else that I could explain a little bit better, or that I should go back to in the, what's it called, in the slides?
I think the only thing I have is with the functions.
Mhm.
Technically, could you also just put the same code within the loop and just run it? I guess like
Absolutely.
you're using it multiple times in a loop, or like you're using it in multiple points in the code, it's easier to make like a function for it, right?
Yeah, they got a little fancy with the functions over here, but nothing wrong with that. You could have absolutely just included this code into the looped area and not use the function. Um, be the same either way. I'm not sure if how that would affect the runtime or the speed at which the code is read. For something simple like this, that's not really a concern, but might be as you make something more complex.
Okay.
Mhm. Let's see. You can also send some. Okay. Well, that's all that I had for this. I think we can wrap up the formal workshop with that.
Yeah, this was great. Thank you so much.
Yeah.
Yeah.
Another